Flat Earth Proof 11. Outer Space. The Earth. Wait for it. Wait for it. It's supposedly here. An insignificantly tiny speck, they say. Somewhere in this vast vacuum. Ah, yes. The infinite vacuum of space. Said to be in direct contact with the atmosphere of Earth. Yes? But the atmosphere is, of course, gas and should expand indefinitely to fill its container. But since the container of Earth's atmosphere is the entire area of space, then it should follow the second law of thermodynamics and establish equilibrium, as is the case in every single experiment ever conducted. In other words, after the alleged 4.5 billion years of Earth speeding around the sun at over 100,000 kilometers per hour, the atmosphere should have long since dissipated by now. But there's gravity, people argue, maintaining the atmosphere perfectly. Right, whilst of course allowing simultaneous cross-directional winds to blow, insects to hover, birds to take off and fly, smoke to rise, not to mention helium-filled balloons, etc., etc., notwithstanding that it has never been shown that any object will attract matter to it due to its mass alone. So, let's just turn to investigate the vehicles of space and ask, can rockets work in a vacuum? A logically necessary question. Well, to answer, rockets require matter to push against in order to move forward. And according to repeatable experiments, rockets simply spin violently out of control when placed to function in a vacuum. Now, consider during Apollo 17 how the astronauts were able to capture the blue marble image at only 1/10 of the distance to the moon. This is akin to taking a picture of the runway from an airplane shortly after takeoff. This fact alone raises suspicions, but becomes even more apparent when one realizes that NASA only releases rear-facing footage from their rockets, and never forward-facing footage. But NASA admitting to the threat of drowning in space is the loudest testimony against their charade, with bubbles being caught rising on spacewalk footage, supposedly being carried out in the vacuum of space. Really? What substance is lighter than a vacuum so that it can rise in it? So investigate the subject for yourself and ask questions.